Hey guys, how's it going? Just been working on this little utility that goes along with a grease weasel that I have here. Um, Basically, what it allows you to do is take the images, the SCP images that you capture with the grease weasel and converts them to CoCo friendly formats. So as an example, I've got a disc here. This is Medieval Madness by Dicom Products. For folks that may be familiar with this, it was a shooting game, but this particular game, as much of the Dicom products were heavily copy protected. So just going to show you how the flux level copy and the transfer export utility that I'm putting together allow you to basically not just copy protected games. I mean, that's not what this is for. It's to take and create a flux identical copy of the data that you have on these disks for archiving purposes. So I'll go ahead and put this in the drive. And I'm using an 80-track drive here. The disk itself is, I believe, either 35 or 40 track. So what we'll do is we'll go up and we'll pull up our command prompt here, and we've got grease weasel all set. To do a copy of this, what we need to do basically, let's see, we do Python, do grease weasel, greaseweasel.py, and we'll do a read. And I'm going to put some parameters in here. I typically do 3 revs, so it'll do 3 separate track reads. And we'll do a starting cylinder of 0 and an end cylinder of 79, 0 through 79, that's 80 tracks. And this is a single-sided disk. Let's see, single, can't even type. And we'll just do Medieval Madness .scp, and my grease weasel is on COM25. So we'll see if this this works here. I think I typed it in right. So as you can see, it's reading the tracks. You can see the grease weasel flashing over here as it's reading each track, and then the motor, stepper motors coming down closer to the center of the hub as it's reading the disk here. So it'll go through and it'll read all 80 tracks. And if all goes well, we'll have a perfect flux level copy of the disk. Now this is going to be quite large since we're doing bit cell values. This disk, even though it's like a 180K disk, it'll probably turn out to be about 15 to 20 meg when we're done here. So one of the nice things with this is if you do have a lot of floppies, you can do perfect bit level archive copies of these where you would never have to touch the drives again or the disks again, and just for historic archiving purposes, just create a permanent backup of those disk images. Okay, so it's all set, and we'll do dir listing here. And there's our file, and it's actually 21 meg, so it's quite large, much larger than the 180K for a single-sided floppy that would typically be what a CoCo disk would be. Okay, so from there what we're going to do is we'll pull up my utility that I've been working on, and it's still very crude, but I have enough functionality here to show you what it's actually doing. So I'll go ahead and we'll open up this image that we just created here. And we want to go to my desktop and Grease Weasel, and there's our disk image there, so 20.9 meg. Go ahead and open, and it's reading the floppy image. You can see the progress bar here. It takes a little while to load, and then now it's parsing the image, and should be done in a few seconds here. So we'll do raw track mode. So this is the actual bit cell values converted to byte level interpretations. So you can basically see that there's a few different revolutions here. They're more or less the same. You can come in and you can take a look at what the raw sectors look like. And then you can also do parse sector or parse track. Since this is a 80 track copy, every other track is going to be garbage because the CoCo disc is double-sided. It's not, or double density. So every other track is going to be garbage. So you can see as we go through here, we've got null values. Oop, I'm looking at sectors. So we'll go and look through the tracks. So we have a bunch of garbage in there. If we want to take a look at the directory listing, what I can do is go to, it would be track 17 normally, but if we go to track 34, there is our directory track. So we're seeing what the actual physical sector is here, and then the logical sector as well. So physical sector 1, but this is logical sector 1 as well. So this is logical sector 2, which means this is our file allocation table, and you can see the information there. And it looks like they might have had a backup of the directory or something in here as well. So we'll go, and there's logical sector 3. So this is the actual directory listing here. So from here, what I can do is I can do an export, and I want to export this to DMK. I'm going to do 40 track, and it's single-sided. I'm just going to do side 0. We'll do a browse, and we'll just name this Medieval Madness.dmk. Save, and then we'll do an export. So we'll minimize this, and then what we'll do is we'll bring up VCC, make it a little bit easier, and we'll insert the disk image, and need to do a search for that since VCC supports DMK, but we don't have that as a native. So we'll go ahead and load that there, do a dir. And you can see the directory listing, medieval, and if this doesn't work, then the disk is just going to cycle over and over and over again as it's trying to do the copy protection, get through it. But if it does work, it should go into the game, so we'll see. So there's the title screen, and it's trying to load, and it looks like it's going to load, and there you go. So we have a DMK image of the disk that's usable for using in the emulators, and then another option which isn't implemented yet is the SDF export, which would allow you to use with the CoCo SDC. So there you have it. So that's the demo for now. More to come later. Take care.